Hello again, guys. This is part 3 of the grade 12 probability series. In this part, we're going to be talking about identical objects. So if you're new to the channel, I'd like to welcome you. Or if you have missed the other two parts, please go back and watch those ones. That way you'll be able to actually understand what is happening right here. Alright, so now here, let's go ahead and jump right into our questions here. So here, consider the word Johannesburg. Now, repeating letters are regarded as identical. Now, in this case here, when you're talking about identical objects, this is what we do first, right? So the first thing that you need to do when you look into your diagram is to count the number of letters that you have, right? So now here we have 2, 4, 6, 8, 10, 12. So here, the options that we have, it is 12 options, right? And then from there, you're gonna then see if you have letters that are identical here, and you're gonna count those identical. So I'm gonna write here identical letters, and then from there we're gonna write which letters are those, right? So in order for me to understand those letters, I'll just check here what do we have here. So firstly, I'll start with J. There's only one J here, and then there's only one O here, and then there's one H here, there's one A. And when I'm looking at N, I see there is two N, so which means now the first identical that I see here, it's N, and then there's two of them, and then there is no E, there's no S, and then there is no B, there's no U, there's no R, there's no G. All right, now this is the only identical letter that we have here. Now, for now, if you don't understand why we're doing this, you're going to get it as we answer this question right now. So let's go ahead and look into the first one now. Now, the first question here, it says, how many different arrangements of the letters of this word are possible, right? So now, when you calculate the arrangements here, right, what we do, or what you do when you calculate the arrangements is, firstly, ideally, at first, when we had a question like this, right, or questions like these, you'll just basically take the options and you write it as a factorial, right? But then now in this case, it is different because you have letters that are identical. So to answer this, or to get the arrangements, what you have to do is you will still take the first part that we did, which is 12 factorial, but then now you will divide this by the letters that were identical. Now here we had two n's, so which means now here I'll say 2 factorial, right? 2 factorial. Now if you're wondering why we do this, right, the reason for this is because when we are arranging, right, we have these two n's, right? So sometimes the first option can either be this n, and then this is going to be the second n, or this n can be the first one, or this can be the second one. Now, because of we don't know which one is which, we then divide by that 2 factorial, right? So that is why we dividing like that. Okay, so we got our answer. Now let's go ahead and look into the second question. The second question says here, if the letters of this word are arranged randomly, right, what is the probability that the resulting word will start with J and end with G? All right, so now here we're looking for the probability, right, that the word will have to start with J and end with G. Okay, so now here it means now we're gonna basically have to do our event. Now, how are we going to be doing this event? So here, just like we did in the previous video, the first letter or the first space, right? So let me just write this 1, 2, 3, 4, 5. All right, so here we have our spaces. So yeah, because of it said the first must be J and then the last must be G, it means now we know that here we only have one option, which is J, and then we only have one option, which is G, right? And then after that, here we can put any letters. So if we have already used one letter and we use another letter here, that means we have 10 options left, right? So this will then be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, or also known as 10 factorial, right? So now this then means now, therefore, that our arrangement, right, will have to be 10 factorial, right? But then now remember we still had identical letters, which is n, so now this will be over 2 factorial. Now that is going to be our event. Now to get the probability of this, we'll take our event 10 factorial divide by 2 factorial, and divide it with our original or our outcome that didn't have any restriction, which was 12 factorial over 2 factorial. Now in a calculator, how would you press this? Because people might struggle to actually do this one. So to calculate this one in a calculator, you have to press a fraction, and then after that just open those two brackets, and from there open a fraction, right? So this is going to be 10 factorial, right, over 2 factorial. And then you're going to do at the bottom the same thing, two brackets, you press another fraction, then it will be 12 factorial over 2 factorial. Then you're going to press the answer. Now that will be our probability. So it is 1 over 132, and that is going to be our answer. Now that's it for this one for now. Now in the next video, it's going to be probably our last part, but in that one we are going to be revisiting this identical object, but we're going to be combining with what we're going to be covering into the next part. And I'm going to see you on to that one. Cheers.